Okay, so I wasn't sharing the full screen earlier, so I couldn't show my graphs very well. Behind me here is actually an adobe wall here in New Mexico. Our place doesn't even have air conditioning, but the adobe actually keeps it cool. So paying Edmond electric bills, I'm very jealous of being able to forego an air conditioner, right? Uh, so let me show you that graph now that I can. This is it. Okay, so apologize for that, but here's df of 1 and 2 and 3 as it approaches um, what seems like an impossibly high amount of degrees of freedom, realistically applicable to research. But and in psychology, I mean, really, I guess like the less degrees of freedom you have, the more important it is that we're using statistics because of how it adjusts our confidence in whether we've explained an effect. Um, but if we did have 10,000 categories, then we approach normal distribution here. So I have a couple more minutes. I have some empirical data that I gathered uh, in interdisciplinary research with the Department of Education. I worked as their quantitative analyst. Um, I'll pull up that data. Oh, I got too many tabs open or windows open. None of this is identified right now, so it's okay what you're looking at. But we have here, this is I'm showing an example of non-parametric data, something we'd use for this distribution. So here's case number of all of our participants, and these all are different items on a scale that assesses teachers' attitudes towards technology. We were specifically interested in secondary teachers. My co-researcher was uh, at the time student teaching. So we assessed two schools, so that's two categories by three uh, possible observations that we could have gathered from each participant. Um, I, I, I don't know if this is a no-no, but I was interested in a novel analysis using this item scale. The item scale is supposed to be, or is generated as a composite, but in an arguably more descriptive and uh, qualitative, you know, kind of design, um, something exploratory. I wanted to see if each of these individual questions had a general consensus among the teachers. So we recorded each teacher and whether they agreed or were neutral or disagreed to each question. So here's one question. Technological tools do not need to be used in instruction. Um, we had a relatively small, well, we had a small sample because since this was mixed methods, we did lengthy interviews with each individual case. Um, but I was able to stick in there the scale to hopefully find out some more stuff. So we have two different schools here. So 15 here at Piedmont and uh, 20 from Pioneer. And this is whether they agreed on do technological tools not need to be used for instruction. So I would say I would test this chi-square and test the frequency of each answer in in comparison to the other answers. So disagree won here statistically, demonstrated by the significant chi-square difference in the frequency, right? So the non-parametric data rather than neutral and agree. So in my research, I would call this a negative general consensus amongst the teachers. And there doesn't appear to be a significant difference between the two schools. So that's really a sampling test, so to make sure that our samples are the same. To get on to how it applies to the distribution demonstration, I have 1, 2, 3, 4, 5, 6 categories in this data. So we take 6 minus 1 and get degrees of freedom equals 5. Let me find the chart. So this is the distribution that we would be assessing with our data, is degrees of freedom equals 5. And we can see this stark contrast between, if we were testing these 6 categories, between whether if we were just testing for 2 categories, the difference in distributions there. So I think that's it. I think my time's up. So I want to thank you for watching my video. Have an awesome day. I'm gonna enjoy the rest of my vacation.